Welcome to 4.5 extension. It's called an extension because it's not really a whole section. It's just a little bit more. But anyways, let's review a couple of things about right triangles. First and foremost, this is our 90-degree box, which is our right angle. That's super important. And ladies and gents, opposite of that right angle always is your hypotenuse or your hypo. Okay, it's going to be opposite the 90-degree angles. And ladies and gents, that means the other two sides are known as the legs. So the other two sides. So today we're going to talk about what's known as HL, or hypotenuse leg. So since we're trying to prove triangles congruent, the idea is that we can go ahead and have a hypotenuse and one of the legs. And that's what our theorem says here. So go ahead and hit pause. And it says, again, this is hypotenuse leg, which is for right angles only. Right triangles, I should say, is that you need to have your hypos. Notice I have a hypo, and then one of the legs. It doesn't matter which one, okay? It's one of the legs, okay? So, ladies and gentlemen, angle, side, side, angle, side, side only works when it is, ladies and gen, HL. Alrighty, so let's take some proofs for a spin. So, when we set up our key here, I still have SAS, I have side, 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 angle, 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 side, and I'm going to add HL to the mix. And remember, the CPCTC is afterwards. So if I were to give you a piece of advice for here on out, write this every single time you're proving triangle congruence or doing proofs, okay? So let's see what, and one last thing I should mention is that just because we're doing HL today doesn't mean the right angles, okay, they can be used in angle for SAS or angle, or angle, side. So it says it right here to start that angle ABD and angle CBD are right angles. And that's given, so we'll go ahead and put that in there. Boom. And then it's going to tell me that AD is congruent to CD, and that's also given. So AD is our hypos. So I'm going to put hypo right here, just to keep that in mind. Alrighty. So the first thing I need to do is, ladies and gentlemen, is go ahead and say, what do we got going on here? So I have one set of sides. We have the hypos. So side, side's probably out. SAS is probably out. I'm going to stick with these two for the second, but HL is where I want to go first. I have my right triangles because those are right angles. Okay, so we're good to go. So the next thing I'm going to go ahead and say is that BD is going to be the same because they're used in both triangles. So BD is congruent to DB, I should say. And that's reflexive. Anytime, ladies and gents, you share something, we're going to go ahead and say that that is reflexive. And then, ladies and gentlemen, boys and girls, we're set to go. So we definitely have HL on our list here. So I'm going to go one tick mark to two. So triangle ADB is congruent to triangle CDB, and that's HL congruency. Ooh, love that HL. It's like the super shortcut. All right, let's go to number two. Ooh, we have some more right angles again. So side, sassy, frass, angle, side, angle, side. HL gives me CPCTC. All righty. So let's write down our given. So it says FGH, boom shakalaka, is a right angle, and that's given. And we might as well do the next one. So it says JHG. HG is a right angle. Boom shakalaka. Put down our given. So anytime we have a right angle, I'm thinking HL right off the bat, but it doesn't have to be HL. But let's take a look at what we got here. We have FG is congruent to JH. So FG and JH. Boom. So this would be considered to be a leg, right? We got our legs over here. Boom. And that's given. All righty. We are trying to prove that, let's do this right here, that FGH, and we have then JHG, those two big triangles are going to be congruent. Well, ladies and gents, I do have my legs, which is super awesome, but I don't have any hypo. And there's no way to say that those hypos are the same. I can have vertical angles right here, but that's not inherently helpful for my hypos. So I'm going to go ahead and say, sorry, HL, it's been real, it's been fun, but you're off the list. So obviously, I'm going to take those off. Well, let's keep SAS. We'll take side, side, side off since I don't have the hypo. But I do notice that those triangles overlap right here. So we're going to say that GH is congruent to GH, and that's reflexive. Now, the other thing we have to remember here, ladies and gentlemen, boys and girls, is now that we're not using HL, this 90-degree box right here is super helpful. However, we have to say that those angles are congruent before we use them. So I'm going to say that angle FGH is congruent to angle JHG because of the right angle theorem that says all right angles are the same. Don't mind the beeping in the background there. All righty. So it looks like I got a side, an angle, and a side, so we're sassy frass all the way. So triangle FGH is congruent to triangle JHG by sassy frass congruence. So just because we have added HL to the list doesn't mean that everything is HL today. Fun fact of the day. Alrighty. Moving on. Oh, look at all the perpendicular stuff. I dig it. Side, side, side. Sassy frass. Angle, side, angle, 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 side. And new to the group is HL. Don't forget my CPCTC. Alrighty. So I know that AB is perpendicular to BC. And that's given. So we'll put my 90-degree box right there. And I know that DC is perpendicular to BC. 90-degree box right there. Alrighty. And then last but not least, we have the AC. So this whole kit and caboodle. And this BD, this whole kit and caboodle right there, is the same. They are congruent. So, ladies and gentlemen, the first thing I'm going to go ahead and say is it's perpendicular. That means 90-degree box. So I'm going to say that angle ABC and angle, well, we should probably do one at a time, is a right angle, and then angle DCB is a right angle. And the reason is the definition of perpendicular. Definition of perpendicular. Remember, we talked about this in previous videos. If they give you important vocabulary or symbols, in this case, probably should define those to help you with your proofs. And since we have done that, we know boom, boom. Now, I'm going to go ahead and take a look at what we got. Because I have right angles, I'm thinking HL. So let's go ahead and see what side this is that we have in orange. That is your hypo. Ooh, is there any way that those two triangles share a leg? They do. So we're going to say that BC is congruent to BC. reflexive. Yay! The triangles are the same. So I'm going to go ahead and do a boom. So let's go ahead and do our first triangle here. So triangle CBA is congruent to triangle. We'll go BCD by HL congruency. And then we run around with our hands in the air and go, yay! But no! No! The added bonus of saying we're not done with this proof yet. Because it's saying, don't prove the triangles are congruent. Add that these last sides over here are congruent. Oh, whatever will we do? If only there was a way to say after we prove the triangles are the same, I could say that everything else is the same. What? So after we use our weapons of mass geometric destruction, that's what I call these bad boys, or we use our shortcuts, we can use and say CPCTC, bringing it all full circle. So, ladies and gentlemen, boys and girls, we're going to say that angle AB, this last piece over here, and DC, this piece over here, are going to be congruent because the corresponding parts of congruent triangles are congruent. Drop the mic. It's been a wonderful day. Short video because it's technically not a full section. It's just an extension. We'll see you next time here. Take care.